this video, we're going to explore a problem relative velocity in 2 dimensions. So in this case, we've got a boat which crosses a river at 10 meters per second, which is 2 kilometers wide. The boat is traveling relative to the surface of the water and points directly across the river. The river is moving at 15 meters per second downstream relative to the bank. We're going to find what is the boat's velocity relative to the bank, how long does the boat take to cross the river, what point does the boat land on the other side, and what vector should the boat take to arrive at the far bank directly opposite from where it sets off. Okay, so let's have a look at the solution. So we're going to be looking at A, what's the boat's velocity relative to the bank. Now to help us, we need to draw a diagram first. Okay, so very quickly we'll put down a diagram. So here are the 2 banks. I'm going to label point A and point B for directly opposite, and here's my boat. I know the boat is travelling at 10 meters per second. So I write that down. I know that the current is travelling at 5 meters per second downstream. So I'm going to say going from left to right is downstream. And this is the bank here. Okay, so for A, I've got to basically determine what is the relative velocity to the bank. So I'll just write that down. I'll call that VB. Okay, so because we're going in 2 dimensions, I'm going to make a triangle. That's going to be made up of my boat's velocity, 10 meters per second, the current, 5 meters per second, and the double arrows is going to be my velocity as seen from the bank. So the boat relative to the bank, BRB, is going to be the square root of 10 squared plus 5 squared, which is square root of 125, which equals 11.2 meters per second. I then need to find an angle. Now the angle in this triangle will be tan to the negative 1 of 5 over 10, which will give me an angle of 27 degrees. Now if I want to find the angle relative to the bank, it's 90 minus 27, which equals 63 degrees, relative to the bank downstream. So my velocity of the boat relative to the bank will be 11.2 meters per second at 63 degrees downstream from the bank. So that's question A sorted. Okay, let's look at question B. Now question B wants me to work out the time taken to cross the river. So we know we're travelling at 10 meters per second and it crosses the river, which is 2 kilometers wide. So basically I've got to use the algorithm speed equals distance over time. Time will be the speed divided by the velocity when I rearrange it. So the time will be the distance, which is 20,000 meters, because I've converted it into meters from kilometers, divided by the speed, which is 10, which basically means that I've got 2,000 seconds. So it's just under an hour. So I know my time is 2,000 seconds. Now I want to work out how far downstream will the boat travel if it follows this path. So I know the time is 2,000 seconds and it's carried downstream at a speed of 5 meters per second on the current. So basically at 5 meters per second for 2,000 seconds, that will give me how far it will travel. Now I know that the velocity of the current is 5 meters per second, so I use speed equals distance over time, rearrange it to find the distance, v times t. So basically I've got 5 times 2,000, which basically means that the distance traveled will be 10,000 meters or 10 kilometers downstream. So it's gone way downstream if it's on this current. Now finally for D, I've got to work out a vector which will allow me to go from point A to point B, which is directly across the river, as we can see here. So I'm going to have to go upstream. Now I know I'm travelling at 10 meters per second upstream, and I know the current is travelling at 5 meters per second downstream. So basically what I'm going to have to do is to produce a vector triangle. The vector triangle will be made up of the current and the velocity at 10 meters per second. Okay, so here I'm going to put my velocity in at 10 meters per second as my hypotenuse. The top line will be my current. Okay, now I know I'm travelling at 10 meters per second, so I'm going to have to find that angle, which is going to be x, to the riverbank. Okay, so my magnitude, basically my size of my vector, is 10 meters per second. This is what was stated in the question. So I'm now going to find x. Now angle theta obviously will be the angle inside the bank, and I'm going to find it from x. So theta, I'm just going to write it down here, is the angle from the horizontal, from the vertical, or directly opposite. And you can put any angle in there, but I'm going to use x, which is 90 minus, so it's going to be, in this case, sine, because I've got the opposite over the hypotenuse, 5 over 10, is going to give me 60 degrees. So the vector I'm going to have to make is going to be at 10 meters per second, 60 degrees from the bank upstream. So I hope that makes sense. Thanks for watching.